Hey, hello, and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, reverse level order traversal. So the problem says is we'll be given a binary tree of size n. We need to find the reverse level order traversal. That is, the traversal must begin from the last level. So let's see through an example. So let's first see what is a normal level order traversal. So what the normal level order traversal says is we need to return the elements according to the level wise. So the level starts from the first level, that is this one. So this is the first level 10, the root node. Then the next level is this 20 and 30, 20 and 30, right? And the next level is then 40 and 60, 40 and 60. So we need to return this list, the list in this order. Okay, that is a level order traversal. Okay, now what the problem is saying is we want to return the reverse level order traversal. So what is a reverse level order traversal will be? So the elements will be starting from the last level. So what they will be, for example, 40, 60. Okay, so this is the last level. Then this is a second last level, 20 and 30, right? And then this is a again the last level. Okay, so this is 40, 60. So this we have to return in this one, right? In this order. That is the elements starting from the last level. Okay, last to first. Okay, now for the simple level order traversal, right? For this level order traversal, generally what we do. So we do the breadth first traversal of this binary tree, right? We do the breadth first traversal of this binary tree. Okay, and how do we do that? We use a queue data structure. So what happens is, for example, let's say we have a queue, right? We have a queue here. Okay, and you know the queue works in the FIFO order, right? So what do we do? So first we add this element 10 to the queue. Okay, we do this, right? And then we go into the while loop, right? Until this queue is empty. This queue is not empty, basically. So we keep on processing. Okay. So once we enter the while loop, we remove this element, this node, okay, 10, right? We remove this element, and what we do, we add into the resultant list, okay, the list which we want to return. And after that, what we do, we check for the left and right child of this node. Okay, if we have. So first we check the left child. Yes, we do have this left child. So what we do? The left child of 10. So what we do? We insert in the queue. Then we check for the right child. If it is there. If it is there, then we are going to insert in the queue again. Okay. So we are done processing this 10. Now we come, okay, again into the while loop. We check whether the queue is empty. No, it is not empty. So we continue processing. Now we come here. We remove this element 20, right? We then add into the result the data, right? Into the resultant list. Then we check for the left and right child. The left and right child of first the left child, yes, it is there. So we add in the queue. We check for the right child, yes, it is there. We add in the queue. Okay. Okay. So in this way we proceed, right? In this way we proceed. So we are done processing 20. Now we come to 30, right? We remove 30, right? We remove 30, and then we check for the left and right child. We don't have any left and right child. So we add, yeah, before checking for the left and right child, we add into the resultant list. We added that. We don't have any left and right child. So we are done processing 30. Now we check for whether queue is empty. Queue is not empty. So we remove 40, right? We check for the left, we add this 40 into the resultant list, and then we check for the left and right child. We don't have any left and right child. We are done processing. Okay, 40. Then we check for the queue, whether queue is empty. No, it is not empty, right? So here we remove 60. We check for the left and right child. We don't have. We also add in the resultant list. So in this way, we do the breadth first traversal for the normal level order traversal. Okay. So this was the simple level order traversal. Now what we want to do is we are again going to use the same. We are again going to do the breadth first traversal. We are also going to use a queue, but there will be slight modification in the normal level order traversal. So let's see what the modification will be. So here, right, we want the elements in this order 40, 60, 20, 30, 10, right? So what we are going to do is again we are going to start processing from 10 only, okay, and we are going to add in the queue, right? So we have added in the queue, right, and then we go into the while loop. We process till queue is not empty, right? So we remove this element 10 from the queue, okay, from the queue. Now we are going to add, yes, we are going to add into the resultant list. So this 10 we have added. Now what we're going to do is, rather than first looking for the left child, and then the right child, we are going to first look for the right child, for the right child, right? So what we are going to do, we are going to check if the right child is present or not. Yes, it is present. So we are going to add in the queue. Okay, we added in the queue. Then we are going to check for the left child. Yes, if it is present, then we are going to add in the queue. So we have added, right? So we are done processing. Okay, so we are done processing 10. Now we are going to process this. We are going to check if queue is not empty. Yeah, it is not empty. So we are going to process, continue processing. Okay. Now we are going to remove this 30. Okay, we're going to remove this 30 and we are going to add into the resultant list. Okay. Then we are going to check for the right child. So it isn't there. Then we are going to check for the left child. It isn't there. Okay, so we are done processing 30. Right? Then we are going to check whether queue is empty. No, it is not empty. So we will continue processing. Okay, we are going to now pop out 20. Right? We are going to now pop out 20 and we are going to add into the resultant list. Okay, then we are going to check for the right child. If 20 has the right child, yes, it does have. So we're going to push in the queue 60. Okay, then we're going to check for the left child. Yes, it is there. So we're going to add in the queue. Okay, so yes, we are done processing 20 now. Okay, now we are going to check for whether queue is empty. No, it is not empty. So we'll continue processing. Okay, so now we are going to remove the 60. We remove the 60. We are going to add in the resultant list. We are going to check for the right child and left child. No, we don't have. So we're done processing 60. Okay, again we come to the queue. Here we are going to remove 40 now, right? And we are going to add now into the resultant queue, right? 40. And we're going to check for the right child and left child. No, we don't have right child and left child. So yes, we are done processing 40. Now we are going to check whether queue is empty. Yes, it is empty. We will stop processing. So here, if you see, we have this order, which is not the same as this one, right? So simply what we need to do now, we have to reverse. We have to reverse this list. So what the reversal will be? So 40, 60, 20, 30, and 10. So this is what we want, and this is what we are going to return. Okay. So now let's see the code. Before going to the code, I would request you to subscribe to my channel, like the video. Thank you so much. So we'll see the Java code first, followed by C++. Okay. So here we take Q. Okay. Node Q equal to new linked list, right? And then we are going to add node into this, the first root node, that is a 10 in this case, right? 10. Okay. Then we are going to have the while loop. Q is empty. Q is not empty. Okay. We are now going to remove the current element. Okay. The first in, first out, node dot poll. Sorry, Q dot poll. Q dot poll. Okay, we remove the first element, whichever is the first element. Okay. Now we are going to have one result list, right? Array list, which we need to return, right? Result equal to new array list. Okay. We are going to add this cur dot data. Okay. Now we're going to check for the right child, right? Cur dot right. If it is not null, it is not null, then q dot add cur dot right. Then we're going to check for the left child. Left child, right? So we are done coding here. So what are we doing? We are first checking for the right child. If it is there, then we are adding in the queue, right? If, then we are going to check for the left child. If it is there, we are going to add in the queue, right? So we have, yeah. So we are adding all the elements, right? When we pop out, we are adding the result. Now simply what we're going to do, we're going to reverse the array list, right? Reverse result. Then simply we're going to return the result, right? We found some. Cannot find single node. Q. Okay, let me compile this. Okay. Okay, the test cases have been passed almost. So I would request you to subscribe to my channel. Let's quickly see the C++ code as well. So here is a C++ code, right? So here we have Q, then we are pushing the root, and then we are having this resultant vector, right? And then we are checking for whether Q is empty. We are going to the while loop. We are removing the first element, whichever is in the Q. Then we are popping that out as well. We are adding in the resultant list, right? The vector array. Then we are checking for the right child. If it is there, add in the Q. Then we are checking for the left child. If it is there, add in the Q, right? And then we are reversing the vector. And then we are returning the vector. Okay. So yes, so this is the code. I hope you have understood the solution. Thanks for watching. Have a happy, healthy, and a great day. Thank you so much.